Hello everyone, my name is Devotion Venkat from NECA section. Now I want to discuss about what is orbit and different types of orbit, how they classified into the different types of orbits. First, we these are the major topics we covered in this slide: introduction to orbital mechanisms, the formulas on Earth orbital types like LEO, MEO, GEO, GSO, HEO, and HO. Let's see what is orbit. Firstly, in definition is what is orbit is an orbit is a path followed by an object under gravitational gravity around a large body. Gravity produces centripetal force while velocity provide forward motion. This means we can understand what is orbit. In other words, orbit is a regular and repeating path, which is a small body revolves around a larger body. For a best example, if an orbit is on Sun, the resultant we can say that continuous free fall around the Earth instead of falling straight down. Look at this slide, we can clearly understand that what I previously said, what is orbit. This moon is in Earth is in the center and moon is evolves in one certain orbit, that is moon orbit. It's with the acceleration and velocity, the moon is revolved around the Earth. Second ones. This the formula of gravitational force is equal to F equal to gm suffix of m by r square. Centripetal force equal to mv square by r. For equating both gives the orbital speed p equal to gm by r. In this in previously slide, some say there is some formulas. So the based on formulas we can see this slide what is centripetal force, what is the gravitational force. For the distance between from distance Earth to satellite is centripetal force. Where the satellites revolves the Earth is called gravitational force. This gravitational force, satellites satellites stay in orbit, not fall down to the Earth. This gravitational force is very important. From orbit period and energy. From time period equal to T equal to 2 pi V by P into R cube by Gm, where total energy equal to 1 by 2 mv square, where we can also some derive that orbit which type of orbit based on eccentricity. Where for E less than 0 is called bounded orbit. For E equal to escape, E greater than equal to hyperbola. Based on these conditions, we can set the orbit how to be bounded and how they bounded or how to escape in orbit from or inside orbit. We can say that based on this ellipse eccentricity. Classification by shape. In Kepler's laws, they in first law they derived the equation. For that the equation, we can say that orbit is not a circular; it is a ellipse. So that we can see this slide. How can that set that circular orbit consists radius speed equal to 0, whereas elliptical varying distance and speed in orbit like E less than 0 less than E less than 1. This is elliptical orbit. For a parabolic orbit, just E eccentricity equal to 1. Where hyperbolic E greater than 1. Let's move on to the other side. Orbital elements like semi-major axis and eccentricity, perigee, apogee. Semi-major axis we can easy in orbit. The longest longitude is in horizontal. The half of that is semi-major axis. Where eccentricity is in orbit in ellipse. The center is eccentricity. It defines the orbital shape. What is shape of the orbit? And perigee is the shortest, the closest point from Earth to satellite. Where apogee is the longest distance from satellite. Orbital elements for orientation. Inclination. Inclination is tilt of orbit plane. Axis not equal, where the satellite and Earth orbiter station cross at one point is called axis node. Argument period. It is the closest distance from the point. Argument period we can say that where the orbit is located, and we can track a for future orbit where is revolves on which orbital plane because we can set that based on the argument period. Truly unknowingly, current position of angle which position will include at the h angles we can derive that or true anomaly. Look at this diagram, we can clearly understand in above slides what I am telling it. Like inclination, access node, reference action, to argument of various is long, access node, plane of reference. We can see that diagram, we can clearly understand what in above side I am discussed that we can see carefully and understand it. After Kepler's derived the three laws. First one mainly is pla- planets moves in elliptical orbit, not a circular orbit. A circular orbit. Kepler states that the first law. Then second law is equal area in equal times. That means speed is changed, but not uh, time is not changed. Kepler's third law. T square proportional to a cube. Its bigger orbit takes longer. This follows by Newton gravity. There are these Kepler's laws, and based on distance and time, the orbits can broadly classify into the five types, um, mainly classified in five types like LEO, GEO, MEO, GSO, HEO, and several different times in different orbits. We can use different types of applications for you can use choose different for some outages, transmit GPS navigation systems and experimental videos. We can use that different orbits for this use different orbits. Different orbits and costly increase and decrease depends on which type of orbit we can use that. Let's see the first one by one. We can understand clearly of orbits. First one, LEO. LEO means low Earth orbit. Low Earth orbit. This altitude is 500 to 2000 kilometers above Earth height. The speed of orbit is 77.8 kilometers per hour. It takes one revolution to complete the air around is 90 to 120 minutes or 8 hours. It's taken to complete a one revolution from the Earth. Earth. Uh, low latency is communication and high resolution imagination. This latency in LEO latency is 2 to 27 microseconds latency for delay. This is used for Earth observations and remote sensing and space stations. And also atmosphere drag presence and shorter lifetime. Let's move into another orbit, that is medium Earth orbit. It is above the LEO and from the Earth. Its height is 1,027 kilometers. It is a modern speed and moderated delay. And so this is wider coverage than LEO. LEO is coverage in small area, but MO is coverage more than LEO. So few satellites needed for global coverages, mainly used for a navigation system, and it is also cover. It's also to take revolves one orbit. It take around 24 hours, and its latency is 27 to 477 milliseconds. Let's move on to the next orbit, geostationary orbit. Shortly, we can say that GEO. GEO is above MEO and its distance around 36 kilometers per kilometers. It's exactly above the equator. And this time period is 24 hours to match the Earth rotation. And to take the complete the orientation, it takes 24 hours, and it is equal to the Earth rotational speed and appears fixed around observations and very large coverage compared to the both LU and MU. Its coverage the one by third of Earth. Used for TV broadcast and telecommunication and weather satellites. It is very used for communications. And let's move on to the next orbit, that is geosynchronous orbit (GSO). In detail, we can see it is also above 36 kilometers. We can see this orbit, but not exactly 36 kilometers. Maybe it's difference 2,000 kilometers. We can approximate, but it's will also equal to 24 hours. Must be is inclined on a ellipse. Satellites appears to move in a small figure-eight path. Include GSO is a special case. Useful time synchronization is required. Use it for some communication and tracking. Use it for like GPS, and its latency is 477 milliseconds. Let's move on to the next topic, HEO. HEO means highly elliptical orbit. Highly elliptical orbit used in mostly in Russia for defense and their defenses. And its highly elliptical orbit is travel from north to southern poles, and it's widely covers the we can some weather communications is highly stretched elliptical orbits, which is highly eccentricity. Long dwell time near apogee for the regional coverage. Useful for high altitude and polar regions. He already said that the polar regions we can calculate the weathers and how their behavior and condition we can use it this HUO. We can derive that what is the earth condition, what is the climate. We can say that based on this HUO. Use it for scientific studies and special communications. We can use it that. Let's see the diagram. We can clearly understand that what is orbit and where they located, and how they revolve the Earth. See, like Geo is closer to the equator. In this diagram, you can clearly observe that, and can clearly observe that in each orbit, in different distances, you can observe that. And you can closely observe that HUE is uh, closer to the north and south poles. This means we can cover the entire poles from south to north. From let's see the some different differences and parameters based on LUO, MEO, and HEO and GSO. Some we can see this. This we already know the full form of each of them, understands, and everyone in orbit. Every orbit is circular except HEO is elliptic. Every inclination angle is 0, but GSO is 0 to 90 degrees, and HEO is usually 63.4 and 90 degrees seat inclined at HEO. And and we know how much it time taken in already discussion about the slides, and we can see for the coverage areas. LEO is coverage small area and MEO is medium and GEO is very small, but whereas GEO and HEO is large coverage areas compared to the HEO and compared to GEO and LEO and HEO MEO. Sorry for that. And transmission required power required is low. In LEO, MEO is medium, GEO is high, GSO is high, and MEO is more. Renovation size is small, whereas GEO and GSO is very large, and is very fun. Let's Let's we can see the summary. Orbit results from balance between gravity and motion. Energy and orbital elements fully described in motion. Different altitudes and different purpose you can use like the used in different orbits like MEO, GEO, HEO, and let's keep we can use different parameters and different different orbits in different types of satellites are there like MEO LEO is maybe 50 to 100 satellites are there, and HEO is very small satellites in there that orbit. Mainly used for HEO is highly elliptical orbit, so you can use don't use that so many satellites you can that orbit you can use. Maybe it's 10 satellites are in that orbit. This is the orbit. This is conclude what is orbit and their classification, how they broadly classified, and how orbits are classified based on size and latency and distance and parameters.